Hello everybody, welcome to our first stream of Wire Dev. This is my first time streaming here in Twitch. It's a pleasure. In these streams, basically, we're going to create several applications for cell phones, computers, video games, and in this case, we're going to create an artificial intelligence. Basically, what we're going to create is a artificial intelligence similar to ChatGPT. It's not going to be as complex as ChatGPT. It's going to be very simple. It's a very simplified version. What we're basically going to do is we're going to create something that will be able to read from natural language and decide between two categories. We're going to work with two categorizations for something not very controversial, politics. We're going to decipher if a Twitter comment is left-leaning, or right-leaning. If someone says something that's for a political spectrum to be categorized as a left-leaning or right-leaning comment, this artificial intelligence will be able to know it. How are we going to do that? Well, basically, I'm going to draw here for a bit. Let me see, here it is, okay. Basically, when we write something, like a sentence, for example, this, let me put it bigger. Okay. For example, when we write, this is a sentence I'm writing now. Right? This is a sentence. It's not very complex. And what ChatGPT does is basically using each word and categorizing it. Oh, sorry, here it is. Each of these words are going to be categorized. ChatGPT has a memory of 50,000 words. So we will store each word in a database, and we will give each word a number, because neural networks are not able to read words. They're not able to understand words, only numbers. So if we use a number as a reference for each word, for example, this is going to be the number 1, is going to be number 2, A is going to be, oh man, this pointer is so small. It's going to be number 3, for example. Let me see if I can see a better brush here. Okay, this is better. Then this way, the AI is going to be able to read these words. So basically, ChatGPT is a neural network. Well, I think it's several neural networks. It's more complex than just one, but you can express it as a neural network. Basically, what they are is a bunch of digital neurons, right? Imagine this is a neuron. Oops. And these neurons are interconnected between each other. This is what we call a layer of neurons, right? When they interconnect between each other, like this, they are able to communicate. and they have between these connections mathematical equations that are going to give us an output. Suppose that we have an output here, right? Suppose this is a neural network. This is a neural network. Network. Right? This neural network has two basic components that are going to receive information and output information, right? So, this layer over here that we have here at the beginning, the information flows through, the information flows through this direction, and this is what we're going to call the input layer. Input layer. Right? And this is going to be the output layer. So this is a neural network. These spheres over here are what we call neurons. So these are going to process the information and change the values of these connections, right? So this, let's put this as a neuron. That's neuron, right? Some of the people that are connected here and currently in chat already know this. This is basic information for everyone, so we know where we're at. And what ChatGPT does is they receive each of these words as an input. Suppose that we delete this over here. Let's make this bigger. Oh, this eraser is too small. So when we have 4 words, like this sentence over here, this is a sentence, we can put 4 words in this input layer, right? So basically, what we're going to do is we assign this as a 4, and we add these words over here, right? So we encode these words into numbers, and we add it to this digital brain. This is like a small brain with 4 neurons in an input layer, 3 neurons in a hidden layer, which is this one here in the middle, and this output layer has only 2 neurons. So this is like a small brain, a very small brain with 9 neurons. So that's what basically ChatGPT does. Suppose we have another sentence, like this is another sentence. This value over here, we already have it, right? It's 1. This is 1. This is already 2. But this one is a new word, so we will assign it the number 5, right? And this one, we already had the number 4 here. So these are repeated. So in this case, we just have to write over here we will have to write the number 5, right? And oh well, this is another. That's what we basically do. So this one is being encoded to the neural network, right? So how do we use it? Because okay, we are already fixed, or we solved how to make the neural network able to read the words. We only did that. We are now have to train it to let the neural network know what this sentence means. So what do we have to say to this neural network? For example, we want to say this is, for example, category A, and this is category B. So when we use this category B, let's say that we turn this one on and this one off. This result is always in binary. This input layer can receive any kind of number, but this output layer, in the way in which I have configured it, is it only outputs a binary value, so it will output a 0 or a 1. So suppose we have this configuration, we can say this means A. And if we put a number 1 here and a number 0 here, we can say this is B. Or we can say something easier. We can just have only one neuron over here, and we can add 1 or a 0. We can do that, and we will save a lot of time having only one output instead of 2, because the training process sometimes takes a bit of time, right? This is a computational process that, depending on the data and the amount of sentences. For example, if I want to train this neural network with only these 2 sentences, basically it will be rather quickly, a microsecond. But if we use thousands and thousands upon thousands of sentences, it will take a lot more. And of course, the bigger the data, the better, but trainings are not as simple, because we not only need to have a large amount of data, we have to also have a consistent data in which we don't have contradictions. For example, if I tell this is B and this is B as well, it will be an error in the training. So we have to make sure our data is normalized as well. It's clean, consistent, and of course, depending on the data, a neural network can be biased or wrongfully trained, for example. So it doesn't matter sometimes how powerful an artificial intelligence is. If it's trained in a wrong way, it can be rather problematic. So in this case, I recommend checking your data for training, and we are going to do that as well right now. What we are going to basically do is we're going to take these sentences from Twitter. We're going to pick 2 political figures from the right and 2 political figures from the left, and we're going to compile at least 3,000 tweets from each person. And with that, I'm going to tell the neural network, look, these 3,000 comments are from a right-leaning person, a right-leaning political figure. So that's what we call a assist training. We're telling the neural network these 3,000 comments are from a right-leaning political figure, and then we're going to give the neural network 3,000 more, and we are going to tell them, look, these 3,000 new comments are from a left-leaning political figure. So after that, the neural network is going to accommodate all these connections between the neurons. So when we add a new comment after the training, the neural network will output here in the output layer the result. So that's what we're going to do. Okay, let's get to coding. So what I built, it's a small project using a application builder called JHipster. Let me bring it up here. Most of the links and stuff I share here, I will share with the code of what we create. in, oh, where is it? I will share it through GitHub, so you can download the code and test it, use it, whatever you want, conquer the world. It's very powerful, AI, so you can use it for your advantage. Well, basically, JHipster is a application builder that's able to build a full stack application using React, Angular in the front end, and in the back end you can use Java. So, well, I have some slides here so we can see quickly what's it about. It's a modern web application development. It's very quick, has really nice technologies to use. I recommend it 100%. It's always updated, it's always up to date with the latest trends and libraries. It's important always to use the latest libraries for security, etc. And yes, basically, this is the project. It has a structure in which you have the Java backend and in this case the React front end. So when we run it, we have to run the backend side using Java, and for the front end we have, let me, documents, the stream, the stream, okay. Here it is. Okay. So to run it, I have to run this command from node package manager. Start. Can start. I remember well. Yes. So while it starts, I'll be right back. I will have a run pretty quick. It gives you a lot of things, or generates a lot of things from scratch. For example, all this, the logging process, security, administration. It comes with it by default, and the username admin, password admin is the default admin. It gives you database generation automatically, a lot of stuff. And what I basically did was I created a model that has these characteristics. It has a text. It's called message. It's like a Twitter message. It has a text. It has a bias in which I say if it's left or right, and AI bias, which is the result from the artificial intelligence. So basically, when I write a message, it will be, let me put this bigger. For example, this is a tweet message. From the left side of the spectrum. Yeah. I have to say here, this is left. For example, when we save it, then after we create the AI, of course, right now it's not working, the AI will be able to say here if it's right or left. But before even creating the AI, we have to get the data, the training data, because I think this is one of the most important processes to be able to create not only create the AI, but to train it, right? So, to train the AI, we're going to look into political figures. So, let's find someone, I don't know if chat wants to give me a recommendation. For example, Ron DeSantis is a right-leaning political figure. I think I have already his latest tweets, but let's download them again so you can see how I get them. So this is Ron DeSantis. He's a right-leaning political figure. So to download all his tweets, we have to go to this page. This page, I can share it later. I was looking into Joe Biden as well, who is a left-leaning political figure and currently the President of the United States of America. Oh my. So when you add here the Twitter tag of the person, of the account, this is going to start downloading all the tweets, and it's going to give you an Excel file, an Excel spreadsheet. So it's easier to copy it, to add it to a plain file, for example, or you can build a Excel file reader using Microsoft SDK, and you can do it easier. In our case, we're going to create a plain text file. We're going to copy all the tweets, paste it in the file, and when we upload it for training, we're going to say which side are those comments from. For example, with Ron DeSantis, we're going to say right-leaning. So let's export it. This is a very, very powerful tool. I will share it with the code when I share it with you guys. Yes, basically that's the process. We're going to look into, for example, Bernie Sanders. Bernie Sanders, he's a left-leaning political figure. And when we search for it, and while it downloads, let me have a quick bathroom break. So be right back. I'm back. Thank you guys. Sorry for the wait. Well, okay. Bernie Sanders tweets are now being downloaded, and so when we look into those files, have them over here, you can see, for example, we have here text for each tweet. You see, right? We have 3,000 tweets over here to train the AI. So let's build 2 txt files. Oh, sorry. I didn't have my microphone on, sorry. Okay. So when we create a text file, we can add no, text. So we're going to copy all this right until the bottom. 3,000 tweets. So we paste it here, right? I think I have to clean this for a bit later, but I think it's okay. So we save it. Let me try this again, because I think the encoding before was giving some problems. Okay, no problem. And we're going to create a file for Bernie Sanders as well. This is DeSantis, and this is Bernie Sanders. So when we see the text over here, we see all the tweets. Training artificial networks using tweets, it's really, really nice. It's very powerful because it's real people talking. So it's pretty good. So what we're going to do now is we're going to save each, not the comments, but the words. So each word, we're going to save it in our database, and we're going to assign them a number. And after that, we use that number to feed the neural network. That's what we're going to do. So with JHipster, we're able, let me see, oh, I can't hear, it's over here. So with JHipster, we can create a new entity in our database, which will be able to store all the words. So we're going to create like this. Let me put this bigger. Okay, the hipster entity word. It's going to be like that, just word. Unauthorized access. Oh, this is PowerShell. All right. Okay. So we're going to create a new entity in the database that is going to store the words, each of our words. So the field we're going to add is going to be the name of the word, and you can say here if the name is going to be required. Of course it's going to be required because empty words are unusable for us. We can add another field that's going to be our value, and it's going to be a number. I can use the IDs, but I've been having problems with that because sometimes they auto-generate in weird ways. Sometimes you can delete a word and that number becomes an empty space. So those numbers in these values that we are going to feed to the AI are going to be a double. I think this AI uses doubles. Let me check our... I have a chuleta over here, which is a cheat sheet. Let me see. Yes, double. It uses double. So let me feed doubles into that. Validation rules? No. This can be empty while we configure it. And those are the places where we are going to store all our words. No more fields, no more relationship. You can store relationship, the database relationship over here as well. REST controller. Yes. No. Yes. And now it's going to generate all the code. And it's done. And as you can see over here, it creates a class called Word, which has an ID, which we're not going to use, and has a name, we are going to use it, and the value. So for example, if we add where is it? So here. So now we have a key here. We have to recompile, sorry. Let's do that. We're working with Java, so we have to stop the program from running, the backend, and run it again. Luckily for me, it's quickly. So when we... here we have some test words. And let's see if I can delete them all, because, well, let's delete them one by one. Or let me use... That's the bad thing, that sometimes I forgot to configure that when we create an entity, it doesn't create test data. So what we're seeing here is test data that it creates automatically. We'll delete it because we're not going to use that. But in the case you need test data, of course it saves time, right? What's wrong with this? Oh, here we are. Okay, we have Word over here, and let's see the data. As you can see, all this data we have over here is what we just created over here. Ubiquitous, Virginia. See? But we're going to delete it, so we right click here, truncate. Okay. And when we check it, where is it? View edit data or rows. It's empty. And over here, it's empty as well. So if we do it manually, of course, we can create over here the word D, and we say D, the value is 1. For example, when we create a new word, the word is going to be word, the value is going to be 2, etc. Right? And now we will create the training per se. So for that, we're going to create a entity called training. This training is going to receive a file let's put here Twitter feed file. It's going to be a binary file. Yes, it's required. We're going to add another file that's going to be the AI file, because when we train the artificial intelligence, all that training is going to be stored into a file. So that file is what we're going to use to give outputs using the previously done training. So this is another binary file. It's not necessary at the beginning, so we don't need to be required. We can add maybe a timestamp. Date time, here it is. No. And a status to say if it's successfully trained or not, because sometimes the trainings fail. So let's add just a new status string. We don't need a validation for that. No. No relationships. No. Yes. And this is generating all the necessary files. To run this. And it's on. Okay. So when we see here training, you can see he created a property, a byte property with the file. It has the content type as well, timestamp, and the status. And of course, it also creates all the endpoints for the RESTful services. You can use this link with this over here to get all the words. For example, if you write /API/words, yeah, and the for example, here post. If you create a web request of the type of the post type with this link, you can save a new word. We will see that later. But we can focus more on the AI part, but I can show you those details quickly. All right, let's code. So we made all the proper configuration to start coding, and we will run this project again to be able to see. Oh, sorry. Wow, it will create another test data. I forgot about that, but okay, no problem. To be able to avoid the test data, you can go here into resources, config, Liquibase, fake data. You delete this fake data directory. Where is it? It's here. And in these files over here, there's also something to delete for the test data. You delete this. This is the fake data configuration, so you delete that as well. And the next time we run it, it won't have test data. But since we didn't do that before, when we see here the training, it's going to have some data. Oh, it didn't have data. Okay, awesome. Let's try, for example, this. Let's save testing for here to see if it saves, and it's saved. Let's open it, and this is the different. Oh, they have different lines. So what we have to do maybe is to maybe use a CSV file, but let's see, because I think since the comments are multi-line, maybe we will have problems with that, but I'm not sure. Yeah, I think so. Well, let's see. Let's try it. We will debug that. Let's delete this and let's fill all the code necessary for the training. So this is the web service that was created to add a new training. So when we run over here and let's debug to let you guys see what happens over here. If we debug over here and we put a breakpoint over there, yeah, no problem. So when we run that and we try to save a new training, and we say here, this is a test, then this code gets triggered, and when we see this training, we can see over here training. Oops, what's this? Oh my. Well, I don't know what I did. Oh, sorry. It's this part. It crashed. Let me start it again because it crashed. Let me kill this process. And start it again because it crashed. That doesn't happen frequently. It's pretty rare that it happens. Alt Shift point. See, it's readable, right? Okay. Okay, let's debug again. All right. So let's test this again. What? Let's start everything again because that error. This is a test. Okay. Now it works. Okay. So when we see this training over here, it is looking a bit small, but you can see it has information. It has a file, a Twitter feed file, AI file, timestamp, this text here that says this is a test. So this is what's being run when you save a new training. So this is where we're going to code now. And let us delete this training. And great. Okay. and I'm going to Google how to read lines from a binary file. Java. Buffer reader, I think. I can just save it in our disk, but we have it in memory already. I think it's this one. Let me see. Training. It's byte. It's a byte. A byte array. Right. Training file equals training dot get feature feed file, right? So in this training file we have a byte array, and let's look into that. How to read a line from byte array. This is what I'm looking for. Maybe you use this one. Okay. Let's get this one. This is how I code. I Google everything. I don't remember anything when I code. Some things I do many times, but reading a file I don't do it every day. So when I don't remember how to do something, Google, Saint Google, will hear your prayers. So this is our data, right? What we're basically doing is an input stream that's going to stream all the information to this reader over here, so we can read line by line. So if we do here, line is going to be equals both reader dot read line. So this line, we have an exception over here. So since this can give a input-output exception, we added here into the signature of our service. So if it crashes, the exception can be thrown and catched and thrown. So this line is going to read all the lines from our buffered reader. Let me see if ready, I think. Let me see. I have to Google this as well. Buffer reader. Buffer reader. Oops. Buffer reader. Let's see which one is the best way to iterate a buffer reader. For example, we can't do this because we don't know if we have 100 lines, right? So it's going to be something like this, or a while as well. So yes, we're going to use that. This is simpler. Let's use this and let's try it. If it doesn't work, it doesn't work. Okay, it's here. So line is going to be that. Let's declare here on the top. And let's see if it works. Hopefully it won't crash or give us any problems. Do you have any questions so far? See, the chat is a bit silent, but if you have any questions, let me know and I will try to answer it. And if you have any comments, like for example, Jesus, that's not the way to do it, of course I can listen to you and your recommendations. For example, I had 2 times this and this over here, so I can delete it. Since we don't need it 2 times, let's run it again. Oh, I forgot about something. I think the training needs something as well, something new. It needs the category, because if I'm going to upload a right-leaning Twitter account, I should say it is right-leaning, so I'm going to add that value over here. So to do that, we just need to redo our entity and add more fields and relationships. Add another field, and we will add here the bias. Right? If it's left or right, or better, let's do something like a boolean. Let's say here is right or is left. Is left, and it's going to be a boolean. No, no, no. Oh, sorry. So it created it, but I have to do another thing first. And we have to go to the database. Go over here into training. And I think we have to add manually let me see, because sometimes I don't have to do it, but I think I have to add that new field manually. Let's see. Yes, we have to add it. Let's create a new column called is left. Data type boolean. And it's done. Let's try it to see if it works. Let's see, for example, Ron DeSantis. He's not left, so we leave this like that. Status test. And let's save it. Is left? False. Perfect. Okay, so let's read the file. Oh, we didn't check if it read the file. Let's see. Let's debug. So oh, I copied it in the wrong place. My bad. So this place is when we update the training. My bad. I have to add it here, which is to create the training. So my bad. I have to copy this and paste it where it should be. So my bad. Oh no. I know what happened. Of course, when I regenerated the files, it deleted what I created. So since I lost it, I need to copy that in. Where is it? Here it is. So when we regenerated the file, as you can see, it got deleted in the right side. So this is what we created, and in the right side we lost our progress. But since this IntelliJ idea can save your local story, we didn't lose the information. And let's add the exception again, and we're done. So when we run this, we should be able to print what we read in the file. So hopefully we read tweet by tweet and not line by line, but let's see. Let's do it. Let's create a new training. Save this file, status test. It's not on the left side. Okay. It's reading the file, okay. And let's see what hides the line. Yes, Florida will not turn a blind eye to the danger of Biden's border crisis. Yeah, well, this is a political statement, and it's going to be really good for the training. And it's reading line by line, as you can see. This line is empty. It's reading line by line. So this is beautiful. This is perfect. This is perfect. All right. Okay. Let's do this. I'm going to save each of the comments into the database. So each of these lines are going to be saved over here. Oh, I stopped the project, sorry. Let me start it again. So each of these lines, for example, this is a tweet. I'm going to save it in the database. And after that, I'm going to say over here, oh my, this is all filled with testing data. I'm going to say the bias over here. So let's do that. Let's save that into the database. So if our training dot is left get is left, okay. Else bias right. So this is a simple differentiation that we're going to save, and we're going to create a new message. So message one new message, and this message dot set text is going to be our line, right? Well, we have to check if the line is empty. Oops. Line. If line is not blank and line is empty, this is something we're going to do to validate the line, of course. And if the line has data inside, or if it's not empty, well, we're going to save it. If not, we're not going to save blank spaces in the database, right? So we have to save two things: each word and the messages. So let's save the words first, because the message is something we can do after. Well, let's quickly set manual bias is going to be what we created over here, the bias, right? Left or right, etc. I don't know if we have to fill another thing. Text? No, not else, nothing else. Okay. Oh, we already we also have to import over here. Let me see if they have it over here. Okay, it's something like this. I don't have to inject in this version. Okay. Oops. I'm calling the repository for saving messages. Messages repository. Message repository. This is something I have to do in Java for the constructor, etc. This is going to fail a test suite, so I'm going to delete this test from. This is something. This is a bad practice, but I'm doing it for the stream, for it to be quick, or else I have to change every test, every automatic test, and it's going to be painful, so I just delete the test folder to be able to run it. Okay. So to save this message, we just have to do here message repository dot save message, and we just did what we wanted to do. But we need to save the words as well. So how do we do that? Okay, if the line is empty, we do a for line, or better, string word, oh, let's do a split, right. String words equals line dot split. So what I'm basically doing here is splitting the words in the line by the spaces. So I think this is the space for this. We can check it. So for string word in words, we're going to save each word into the database, but only if it exists, because we can't have duplicates in the database. So we'll do that. So we're going to create a function over here that's going to be called save word. Right? And to save each word, we have to see if we have it already in the database. So how do we do that? Well, first we have to create the repository over here, the word repository, to be able to access it in the database. So we create the word repository and word repository over here. We import it and we construct it over here as well. For those who don't know, this is a Spring Boot application in Java. So we have repositories that through JPA are able to access the database. And we're done here. Perfect. Okay, let's go here. This is the repository that's able to connect into the database, right? We can create here new ways to connect to the database and do queries. So we can do something called JPQL. It's like SQL, but using Java. So how do we use that? We create something like, for example, find by name. Name is one of the attributes of the word. This is oh sorry, not there, but here. If we see word, we can see that one of the attributes is name, right? So if we go to word repository and do find by name, it's going to find all the oh, we have to turn to lowercase for just in case, but you can say over here lowercase, for example, for only lowercase, something like that. Oh, ignore case, sorry, ignore case. My bad, it's ignore case if you want to avoid problems with uppercase or lowercase words, etc. But we're not going to use that. We're going to initialize everything into lowercase, so we have no problem. So what are we going to return? We're going to return a list of words. list word find by name. If we add here string, the name. So when we call this, the database is going to return us all the words that have this name. So here in save word, we're going to create a list of words a word repository dot find by name, which is the thing we just created, right? So word is going to be the word we're going to save, and if by any chance this word is found, then we have this with some information from the database. So word is going to have a value as well. That value can be something like, for example, count. Let me see. Yes, count. So we're going to create a number to be so long. How do I change long to double? Let's Google it. In Java. You can cast it. Double value. Okay. Double value. Oh, this is a primitive, sorry. Okay, no problem. Or maybe I can cast it like this. I can, no problem, perfect. All right. So if words is different than null and words also contain something inside, length, words that, how do you count? Size, right? I forgot size. Start from 0. Then I'm going to save that. I'm going to save that word. Save word. All right. Oh, sorry. It's not just like that. I have to create an object called word. Oh, word. Right, we created a word. Set name is going to be word. And all words set the value is going to be this max number. So each time we save a word, it's going to be a new number, and it's going to be the size of all the words in the database. So if we have one word in the database, the number is going to be 1. If we have 10,000 words in the database, then this value is going to be 10,000. And the next one will be 10,001, etc. So each word has one number, and that's the number the AI is going to use as a reference. All right. Okay, we're saving the words, and we're saving the messages. let's try it. This is going to be filtered. We're going to truncate the database in several tests because it's going to save a lot of trash information and noise. But each test is going to be an improvement for the application. So let's try it. First we have to delete this. Let's truncate that table. Truncate. Okay. All right. We have nothing in Word, nothing in training, and let's create a new training. So let's use this file. Status. This is not left. We are not currently training. We're just saving the data. The next step is going to be the training after that. It's going to take a while because it's 3,000 values, so it's there doing its thing. We're doing word for word. Maybe I have to optimize that code because it's too slow. We can check it in the database. Let's see the messages. Oh, it's transactional, so we have to wait until it ends. This is too slow, man. Maybe this is way too slow. Maybe we can start with half the data because, or less data because this is way too slow, man. I'm saving word for word and message by message, so it has to be slow. But holy moly. I think the memory went down. Oh, it's saving into the database. Great, great, great. It wasn't as slow. I thought it would take more time. So it was successful, I see. It saved all the messages. And as you can see, there was a time that it was saving all the words, but after a while, all the words were already into the database, so it didn't need more. But it's taking too long here. I don't know why. Oh, it stopped. Let's see if the system saved it. The system is running. Oh, here we have it. Awesome. It's saving line by line, so it's not as good, but we can work with this at least for the time being. As you can see, all of these messages from Governor DeSantis are right-leaning, since he's a right political figure. And when we see the words, no words found. I didn't save the words, man. Why? We'll have to check that. Even though we will have to check that. Because it didn't save the words. Why? Select word, it's not saving the words. It's not saving them. Let's see why. Okay. I think this is the the problem over here. Let's check it. Let's check it out. Let's delete our database. Truncate. Let's check it out from the beginning. It's everything empty. Fine. And let's create another training. Let's give it up for Bernie Sanders this time. Oh, it's not debugging, sorry. Let's debug. Because we need to know what's happening there. And maybe this 6,000 milliseconds, we can change it because we will have to wait for a longer time than that. I don't know where's configured. Maybe here. Configuration, service, web configurer, timeout. Let me see if I can find the timeout here in the config. Time. Cache configuration, datetime, Jackson, static, resource web. No problem. Yeah, I'll check it later. Alright, let's do it again. Bernie Sanders. He's from the left. Save it. Let's see what's happened here. So, words. Words is 0. Oh! I had it all backwards. If words is null or if words.size equals 0. That's the correct statement. So I had it all backwards. So if it's null or empty, it means it is not in the database, so we have to add it here. But if this is full, we have to skip that word. So it was my bad. Sometimes I do things backward by error in the statement, in the if statement. Okay, let's do this. Ron DeSantis. It's not from the left, and save. So it's going to take a bit of time. While it does that, let me get a small bathroom break, and I'll be back. We'll be back soon. Okay, we're back. So it's saving the words, saving everything. Seems to be working fine for now. This failed, but I have to change it. I don't know where exactly. Maybe while it does this. Let me see here in the web configurer if we can change that course filter. I don't know. I don't remember. I did it once, but I'll have to Google it. Maybe. Let me see if it's inserting the words at least. Yes, it's saving the words. So we're doing fine. We're going fine. Let's see if we can see it. Not yet, because it's transactional. So when it's finished the entire process, then we will see the update in the database. In the meantime, we shall be waiting over here. But I think it's taking more time because it's actually saving into the database. So another thing, I saw some words that are not as great for saving. For example, links. If I see a prefix with HTTPS, I should ignore that. Well, let's do it. Let's do it. Let's do it over here. Training. Okay, if word or contains HTTP, then it's a link, so we will ignore it. What else? Or if it's empty. Oh, we already. Oh no. So if it's not empty or if it's not blank, it's blank. So if it's the perfect word, then we save it. If not, we don't save it, basically. Wow, it's still saving. So chat, how do you like it so far? Do you have any questions or anything you would like to add or recommend? Let me know. Wow, this is taking a long time. Let's see if we can see where we are at in the file. We're at least 7/8 from the end, so we'll be done soon. But it takes a while. And if this takes a while, the training maybe takes a bit more, but we shall see. Because we are just adding to the database. We still haven't trained the artificial intelligence, but we will do that. I think after a while we don't need to save more words, because after 3,000 tweets, I think all the words, well, I don't know if all the words of the English language can be contained in 3,000 tweets, but maybe we can skip that step, because it takes too long of a time to at least for the stream. I can disable that after this run is completed. Let me see, how are we doing? Let's see. Still. Takes a long time. Well, in the meantime, we can lay the structure of the system. So we have message, right, which contains all the messages. Where's the mouse? Oh, here it is. Man, this mouse is so small. Let me see if I can put it bigger, because it's way too small. Alright, I can see it. Perfect. So we have message, we have word, and we have training. And this is the AI. Let's do it like this. Maybe it's a bit not so beautiful, but all right. AI. So basically, we have a message here. This is a message. Right? So this hello is going to be saved here. Name and value is going to be 1. Then when we do this, oops, this is going to be this, and the value is going to be 2, etc., etc. So in the training, we will add 1. Hello, hello, this is a message. So, those are 5 words, right? Let's add some more here and more here. So hello is the number 1. This is the value 2. Oh, let's put this prettier. So this, put the key number 2. So this will be 3, this will be 4, this will be 5. And in the training, when we train for right leaning, then we're going to say over here that we're going to put at 1 over here. So 1 right and 0 left. And we're going to do the training with all the Twitter messages. Well, if we can. It's done. Excellent. So let's see if it saved all the words successfully. The messages are going to be there. And the words, there we are. These are all the words. We have 50,000 words so far. ChatGPT has 50,000 words in its vocabulary. So we are still not as big as ChatGPT, so not yet, just a little bit. We have 15,000 words, but we have some errors. For example, this word has a quote there that should not be there, so maybe it's already fixed in another place, but I will leave it like that in the meantime. Let's do it now with Bernie Sanders. We have here all the messages from DeSantis as a right-leaning message, and now we're going to do it with Bernie Sanders, which is from the left. So save it, and we're going to wait a bit more. I will do something in the meantime. Maybe when the server throws the timeout error, I will create a button not in this page, but in the training list, a button that will say execute neural network training, because we are saving the training data, but we are not training the AI yet. So we are just storing the data into the database, and we're giving it a structure so that the AI can differentiate between a left-leaning message from a right-leaning message. But not only that, we also encoded the words, giving each word a number. So when the AI will read our messages, they will not read these words. They will only read these numbers as a reference. And I forgot, for example, to eliminate these, to transform everything into lowercase, but I can do it later because we already saved a lot of information into the database, and to do it again, it will take too long. So basically, we're making possible for the AI to distinguish between left and right comments, and also we are encoding the words into numbers. So in the meantime, we're going to do the training function. Let's do it. So what do we need to train? We're using a library called NeuroPH. We can see it over here in our file. Oh, I haven't added it here. Oh wow. Well, I have it here as a reference in the meantime. Yes, I have it here. So we have to add this repository here, SourceForge, into our pom.xml file. Repositories over here, right? This is the way to add libraries using Maven, for those who don't know what we're doing now. And to add the library, this is the library we're going to use for neural networks. It's called NeuroPH. And it's in dependencies, right? Yes. Dependencies, and I will add it here. So when we add this library over here, we're able to use neural networks in Java. And basically I have a cheat sheet here to import all the libraries. I can explain them now to you, ladies and gentlemen. And basically still not adding it. Okay. Let's wait until it stops running to maybe see if I'm compiling it wrong. Since it's running, maybe maybe it's that. Let me yes, I can show you how to, while we read from the, while we save in the database, I will copy all this and show to you step by step what it does. In train, see how this is going. It's still there, little by little. All right. Basically, what we're going to do with this neural network we're going to create 255 neurons for 255 words. So each neuron from this digital brain we are creating is going to have 255 input neurons, right? Right here we're going to have more neurons, more. And the structure we're going to give, maybe it can be like a hourglass structure. I have used that before to establish a encoder-decoder structure. Or we can use, since we are going to have only one output, we reduce it to just one output that will be right, left. So this is going to be 255 words. And we're going to have approximately like 1, 2, 3, 4, like 5 layers. And these neurons are going to accept, for example, in this tweet over here, let's see this tweet. Florida will not turn blind eye, okay? So when we see Florida, we will look into our word list and we will find Florida here. And we will use this value, 0. So in here, we will add 0. So let's go to another tweet, for example. Let's go to a tweet. The second tweet. We are proposing. All right, let's see. We are proposing. We is the word number 14. So we will add here 14. Do you understand now? It's pretty fun. So that's the way either our artificial intelligence or ChatGPT reads words. It uses a reference table that contains the number for each word. In our case, we have 15,000, but ChatGPT has 50,000 words in its vocabulary. It's pretty big. And not only that, they don't use maybe they do. No, never mind. I was going to say that they use letter by letter, but no, they use word by word. I was going to say something incorrect. Let's see if this is done. Wow, still saving. Well, no problem. Let's see how much. Let's see. If Bernie Sanders' comments are. Oh, we still have a bit more to go, but it's way past the half line, so we can wait a bit. No problem. What I don't understand is why this isn't updating, but I can check that later. All right. Oh, I think I used another thing, but I'm not sure. Okay. All right. Well, at first we declare a neural network from NeuroPH. Then we start doing the layers. So the layers are these. This is one layer. This is another layer, right? So what we're basically doing is building our neural network. So we create an input layer, a hidden layer 1, hidden layer 2, hidden layer 3, 4, 5, and finally the output layer. So there are going to be 7 layers. The output size, I was thinking about a size of 2, but I think just one output is better. Sorry. And after that, when we create the layers, for example, if I want the second layer to be half the size of the input size, we can divide this by 2, for example. So we can achieve this form, this triangular form, in which each subsequent layer has less amounts of neurons, a lower quantity of neurons. So we can try that. Input size 4. We can do 8, and finally 10 to get to something like 2, or maybe here 10. Yes, that's better. Let's see over here if this is still running. Still saving. A lot of words. And after that, after creating each of the layers, then you connect each layer to the next one. So for the first layer, which is the input layer, this one over here, we say this is the layer number 0, and we add it to the artificial neural network. That's what ANN stands for, artificial neural network. So when we want to add the second layer, we say this is the number 1, and this is a hidden layer number 1. And after adding the new layer, we connect it. So we use this connection factory object with this function full connect, and we connect the layer number 0 with the layer number 1, and we do the rest. We create the layer number 2 and we connect the 1 with the 2. We do the layer number 3 and we connect with 2 with the 3, and so on and so 4 with 3 and 4. We create the 5 with 4 and 5, 6 with 5 and 6, etc. Oh, the library is loaded. Awesome. So now that the layers loaded fine, maybe it's because this finished running. Yes, it ran. Awesome. So let's stop this. Oh no, I didn't have to stop it. I wanted to check it. Well, let's check it. Let's comment this so we can at least try this to see if the database is being populated correctly with all the words, all the information, etc. Awesome. Let's see over here. See if the words are being saved. Yes, we have 27,000 words, almost 28,000 words. And our final word is beverage. But we have to clean this kind of stuff. We can do that later. And we can also ignore this. Or maybe not, because sometimes when someone is being referenced in a tweet, if that person is from a right-leaning side and this person, the author of the message, is left-leaning side, sometimes the artificial intelligence can learn something from that. So maybe we can leave it there. Let me uncensor quick message over here. Sorry guys, I was answering some questions. Alright, let's proceed. So it's running fine. It saved all the words. Let's check if it saved all the messages as well correctly. Left, okay. We have 10,000 messages. It's not right because it's supposed to be 6,000. But we can fix that later. All right. Here in training, I will add a new button that says train. But first, let's finish this function, this train function. So basically what we're doing here is creating a neural network saying that our input size is of 255 words. Our output size is just 1. We're connecting all the layers over here. We're also saying here that the input layers, the input neurons are this input layer, the output neurons are this output layer. We also are configuring that this is a multi-layer perceptron. A perceptron is a group of neurons, of digital neurons. This is a perceptron. And since we have several layers, we say this is a multi-layered perceptron, right? After this, we inform the system that we created successfully the artificial neural network. Then we create a dataset. A dataset is the object that will contain all the data for the training. So we have an input and a result. So here we're going to do a iteration to add all the messages as input, and if the message is left, this output is going to be left, and if the message is right, right. And that in itself is the assist training. So it's a training in which we are telling the neural network which is right and which is left. So when we add a new message, then the neural network is going to decide. So let's do it. So for this training, I'm going to select all the messages with this message repository. All right. So list message list. We're going to load all the messages. Message repository boom, dot find all. So it's going to find all the messages for messages. All right. Whoa. Okay, let's do it. 4. So we're going to iterate each word from the message. Get text. Oh no, better. Let's do a split as always. String words message get text dot split. We're going to split the word on all the spaces. What? Oh, sorry. All right. Word. So now we're going to transform the words into numbers, and for that we're going to create all right. So we're going to add the words number value. It's going to be word repository, find by name, and we use word, and we get all right. Because this is an array. Get value. So this is going to give us the database number value for each word, right? And after that, we add it into the input layer. Cont, voila, number value. So basically what we are doing, if we have Florida, oops, let me use the pen. If we have Florida has great ... then in this word, in the database, we consult the database, and it's going to be Florida, Florida equal 1. Has is going to be 5, for example. Great is going to be 7. And then we are going to add those numbers here. 1, 5, 7, right? That's what we're basically doing over here. We get the number value from the database. We find the word, for example, Florida. In the database, the word Florida is the number 1. This value is going to give number 1 value. And we add it to this array, input array. Right? And this square here is going to be here as well. And finally, let's left or right is going to be like this. Yes. If message is from the right, get manual bias equals left. So if the message is from the right, it's going to be 1. And if the message is going to be from the left, it's going to be 0. So after that, we say that result 0 is going to be left or right. And we finally add all the rows to the data set. Right? This is the training. Basically. Or, sorry, the data for the training. Now we're going to train. So backpropagation is the way in which we're going to train the artificial intelligence. We're going to set a max number of iterations in case it takes too long. Maybe this number is big or small. We'll see in the training. And we set the learning rule, which is backpropagation. And finally, with this function over here, we learn. We do the training. So let's just add some random message over here. Let's just delete this. This is the file in which it's going to be saved. That's the way this library works. So after the file is saved, I'm able to load it from the disk and save it into the database, so we can have it there. Let's see. These are exceptions I have to give. Okay. So how are we going to relate this into this. Let me see, because I just can add a new file over here. Yes, let's do it that way. Training. AI file is going to be bytes array. Oh, I need to add some other things over here. Let me see. To explain this one. This is to save it into the database, so we can use it again in the future. I will do something not very good, but just because we are doing it quickly in the stream, so I'm setting the same file for the AI file and the Twitter file, because I think the Twitter file is obligatory. I have to change a lot of stuff to be able to save it, but we can fix it later. What else? Dot set status trained. All right, I think that will be all. Next, what we have to do is we have to create the button over here to train the AI. So let's train it. All right, this is time for coding in React. So let's go to the web application over here. Entities, training, and we are here. This page over here is this one over here. So let's add a button over there to train, or at least to try to train, because I think it will fail in the first time at least. Refresh list. All right. Here, okay. I'm going to say here train on click handle train. Oh, right. To create this. I think it will be working now. Yes. So when we click this, it's going to train the AI. Oh, I don't think it has the, ah, yes, perfect, train. Let's change the color as well. Button, class name, to color, info color, success. This application uses Bootstrap, so uses the standard set of colors and warnings, etc. All right, so let's call the RESTful service. So basically, I have to do a get service. Let's get a get service because yes, let's copy all this. Basically, I'm creating a service. Let me see something over here. Public. Okay. No, this is not the one. Yes, this is the one. Okay. Perfect. So basically, when I use this function, I'm going to do the training. Or better, I can do trainings, do training. Trainings, do training. All right. Let's see over here. Okay, perfect. Let's see over here if we're doing fine. And finally, we have to return wrap or not found, this one. Oops. Oh, I'm not saving, right. Training result equals training repository dot save training. Where's this result? Oh my, you're right. This was already created, so what's that optional thing? I've never used that optional, but it's a requirement. So wow. All that. Let me see when it saves it because it's so annoying. Oh, this is the better one. Excellent. This is the better one. I copied the wrong one. My bad. Oops. And we're done. Perfect. Have to oh my god. I think it's optional as well. What's wrong with this now? All right. Now it's fine. Perfect. Sorry about that. And now in our services, I think it's here. Perfect. Training. I remember this well. Copy URL plus / do training. So I'm creating the function that is going to call or consume the service we just created. Training, do training. I don't know. My microphone fell. I don't remember if this has to do with anything. To declare it somewhere. I don't think so, but I'm not sure. API URL. API URL is, yes, this API / training. So we did API / training. API, which is over here. This is the prefix over here. API is the mapping of the services. So it is API / trainings / do training. API / training / do training. Perfect. Resolve. Right. Oh, fine. So let's find these sort entities. So change. Dispatch. Get entities. Okay, and we're going to find here not only get entities but also do training. Right? Hopefully it doesn't crash. All right. Do training. So let's dispatch this also. Let's see if this works. Needs one argument, so I will leave it as it was. Hopefully that won't give us any errors, but let's see. Right. We don't need any parameters, so let's leave it like that and fix this. Training. We see if delete let me see if find all get entities doesn't have anything. let's see if we can delete everything. I think so. We delete this. What is this? Oh. Let's delete this item over here. And let's see if this compiles now. Dispatch, there's no. Where is that exactly? The reducer. All right. We don't need this. We don't need this. Right, let's see. I think it's going to compile fine. Okay, perfect. After this, we have to compile as well to stop this project. Maybe it will work now. So let's see if our training is successful. Okay, it's running fine. And let's do the training. Gave us an error. Let's see if the error is over here. Oops. Method not allowed. Ah, okay. Right. This is wrong. I think this is a get. Yes. I have to, instead of a post service request, it's a get. So I have to get over here. Do training, right? And right now it's doing it. Let's see how it is running over here. It's running. Awesome. The training is running. I had to do some quick fixes over there. I will wait until this is a bit better. Let's see what's this doing over here. It's too much information, man. I don't even know what's this doing. Well, I can see it's training the neural network. It's not giving errors. Maybe I will stop it now to see if we can't wait a long time until we... Let's stop it to see at least what's this doing. Alright, I stopped it. Sorry about that. So, entity, it's saving. Okay. So let me see if we are here at least. I think I will have to debug because I don't know if this is working. Let us see if it started training at least. I don't know where it's printing all that. Let's see. Let's debug. It's the easiest thing to do. At least we know it's working. Let's debug it. And while it debugs, let me be right back. 1 second for a quick bathroom break. I'm back. Thanks for waiting. So since it's now debugging, we're able to see step by step if we're doing everything fine. So let's train it. We're in the right call. Let's see step by step what we're doing now. We set the input size, neural network. We create the neurons. Let's skip all the creation until we get into the training. I don't understand. What's it doing now? It's like saving a lot of stuff, but from messages. Maybe this is the mistake. If I'm doing very unoptimized things, so maybe it's that's the problem. Let us see. Maybe the problem? Yes, that's the problem. When it reads this, it takes a long time to load. How many? 10,000. I think that's the problem. So I have to find a way to read one by one. Because look at that. Ah, okay, perfect. So I need to optimize that first. Or maybe later, let's see. Right, perfect. So we have a 10,000 message list, a list containing 10,000 messages. And let's see if this, for example, is taking all the words. Yes, Florida will not turn. Perfect. Perfect. So the first word is Florida, right? Florida. It found the word Florida and the number value is 0. You remember in the database, right? So far we're doing fine. Florida can't be 0. That's something I have to fix, because the number 0 is invisible for the or not. No, 0 is correct. No, my bad. 0 is going to be assigned to empty values. So Florida shouldn't be 0, but let's leave it like that for now. So since Mr. DeSantis is from the right, so this value left or right is number 1. For Bernie Sanders, it will be number 0. So right now, when the first training, the input, oh, this is wrong. This is wrong. This is wrong. Let's fix it. Let's fix this, because I had to put this in outside this loop, because this loop is doing word for word, and when we get outside of this loop, we're doing the entire line, the entire string. So we're incrementing the information inside of the input in this loop. When we have all the words in the input array, then we add the input array completely here. So this was wrong, and it's now fixed. So yes, perfect. Right now I think it is going to work. So what we can do now, since there's too much information in the database, to make it quicker, we will make the training with a smaller amount of data, because it's too much. So let's do that. Let's do that quickly. Let's delete all the database first. We will delete messages. This is going to hurt because, oh my. We will delete training. And we will delete all the words. Sorry about that. No, the words, I don't have to delete them. I don't have to delete the words. The messages. The words, I don't have to delete the words. Let's delete just the messages. And I will delete the one that contains Florida with the quotes from the database. So let's do that. Oh, it's not running. Okay. We're almost there. After finishing the training, we will be able to test the neural network. I think in half an hour we'll be able to do that. Alright, let's delete this word. And we will also clean the words. Let's clean the words. How are we going to do that? Well, we're going to do that when we're going to save the words. Right? Let's create a function that's called clean word. Clean word. We're going to replace all the quotes with a space, with an empty space. We're going to replace, what else? What else do I have to clean? Let's see if I can find something here that I don't like. Oh, we have to convert it to lowercase, right? We have to replace the dots, the commas. We don't want commas, or I don't think this artificial intelligence understands punctuation marks yet. So finally, let's do lowercase. And return word. Clean word, clean word. And of course, when I'm going to train the neural network, I will also clean the word. It's a way to filter the words, even though we have different kinds of words in the message with lowercase, uppercase letters or punctuation marks, etc. It will be ignored and always will be compared to the database using clean words. So and in here I will change this ignore case as well. Ignore case. All right. And let's yeah, right. So when I'm going to save the word, well, let's do this for having it better, to save only the clean word. That's a good practice as well. I'm starting to code better because I'm leaving too much for later. All right, fine. So let's do another training with a new file that's going to contain at least, I don't know, man, instead of 5,000 lines, let's leave it to 500, right? I think 500 will be fine. Anyway, in any case, we still have the entire data in Excel, so in a spreadsheet. So if we need it for the future, I will share all those files as well in GitHub, so you can try it yourself if you want to use this artificial intelligence for yourself. Okay. This is great. Perfect. So we have 10% of our training. Only 10% of the time we will take something. So this training shouldn't take long. Let's see where we are. Let's clean this up. The output is different with this library, this artificial intelligence library. So it'll take a bit longer. So I don't know where we are in the list, but hopefully it doesn't take long. It's taking longer than I expected. All right. Of course, the ignore case statement is going to affect your performance, of course, but it was way quicker than before. Let's check the data if it was saved correctly. Yes, it was. Perfect. All right. So let's do it with Bernie Sanders now. Bernie Sanders. He is from the left. And save it. So this is not a training. In reality, this is pre-training. This is saving the data and encoding it so the AI can do it, can read it. And after that, we press the training button, and the button is going to use that data to execute the real training. So this is like a pre-training phase by digesting and transforming the data. And after all the data is in the database, the AI will use the data in the database to do the training. So that's basically it. Let me get some Coca-Cola while it is thinking. So be right back. It's going well. So little by little it's going to keep training, and in the meantime we can do the part where we use the training to decipher if a message is from the left or from the right. So I have over here a code for that. Still running. Sorry. So basically what we're doing is we're getting the file from, oh right, yes, so at the end of the training we got this status, so we're going to use that. It's not the best practice, but we'll be quick. Find by status, or get by status, get one. By status, and I have to use this one like this. So the one that was trained successfully will be returned. See if this run. It ran. Perfect. So it added all the messages from Bernie Sanders as well. Some empty messages, but no problem. So, I think some words, yes, there are some words, 28,000 words. This will be things like this, numbers, dollars. This wasn't deleted. We can clear that better in the future. Right now it's not urgent. Let's see. Okay. Perfect. Let's finish with the calculation. Okay, perfect. He's training over here. Get AI file. So basically I'm getting the file we saved in the training. Oh, by the way, let's see if it saved the file, because we need it. Oh, it wasn't saved. Oh, we didn't do the training. We just did the pre-training. So these two are pre-training. I should add here that pre-training. Let's add that so we don't get confused. So let's go training, create new pre-training, pre-training. And in this part over here where we save the training resource, training.status, set status pre-training, so we don't get confused. So this one is a pre-training. Oh no! In update I'm not going to do anything. So this is a pre-training. Oops. And the other one is a real training. So let's do it. Let's do the real training. Boom. And in the meantime, it's running. Okay, perfect. While it trains, I'm going to do the part where we finally get the output from the AI. So if we find a random tweet from anyone, then the AI will be able to tell us if we are writing something from the left or the right. So it's a left-right detector AI. That's the name we're going to give it, left-right detector. Okay, let's see, training, calculate. Okay. Right input, calculate, and string tweet. So we're going to calculate if a tweet, calculate left or right. Calculate left or right from a tweet, right? So this is the input. We can copy exactly what we did in the past. That was splitting the words, getting the words, getting the number value from each word, and adding it to the input. So the tweet, we're going to get the text. Oh, sorry. We're going to split it by the spaces. We get the words. If we have more than 255 words, it's going to break the loop. We get the number value. We add the number value from the database into the input array. Finally, to the neural network we created, we add this input, and then we calculate. And this calculation is going to return a 1 or a 0. So if it's a 1, it's right. And if it's a 0, it's going to be left. So right here, we just have to write result is going to be, let's bring left or right. It's going to be empty for now, but if 0 equals, yes, equals 0 double, then left or right equals left. And what else? Well, we can do this just to right over here. Right, left, result is going to be left or right. Return resultado. Let's see if this trained. I'm still training. Good thing we did the calculation part. So basically what we are doing now, we had this already constructed. So when we add a new kind of word over here, then right here is going to tell us right or left, 1 or 0, basically. That's what it does. Well, it's still doing it. Destroy YouTube. Let's see. I think it ended now. Finally. Internal server error. No. No, don't tell me it didn't save anything. Let's see. Stack Overflow. Oh, maybe it was an endpoint giving some problems. Let's see. We don't need to debug now, so that will make everything faster. Let's see. Let's see if the training... No, it wasn't saved. Oh man. Maybe you have to use less data, man. Let's do that. Less data. Way less data. Let's add just like 50 messages or something. 100. 100 is fine. Just 100 messages, and then we do the big one. Just so we can do this faster, because it's taking too long. It's a bad training with just 100 tweets, but or less. It's not 100. 100 lines, no tweets. Well, after the test, we'll do a big one, I promise. Let's do a quick one. Let's do a pre-training. Bernie Sanders is from the left. And we can skip the word. Since we already saved the words, I'm going to comment it for now. Maybe that will save us a lot of time. We can even save the... no, that's too much. We can save, instead of saving the sentence with words, we can save the sentence using only the numbers in the database. It's quicker and oh, awesome, it's quicker now. You can see all the numbers. Perfect. Let's do now Mr. DeSantis. It's not from the left. Okay. And with this smaller data set for training, we're going to be able to do things quicker, because doing tests that fail with big data is, you lose too much time. So, oh, it was really quick. So doing tests with smaller data is always quicker. After that, we will do a bigger one. All right, let's train. Let's see what's the problem over here. I think it's doing some things several times. That must work. It's doing the training. We're training the AI. And in the meantime, over here, over message, we're going to create the function that's going to use this calculation. Calculate left or right. We can add it there. In message, where is message? There it is. When we create a message, the AI is invoked. Training repository and Word repository. Clean Word. Or should I just... maybe I can invoke this private training. Let's see if I can do that. I don't remember well if this is possible. Yes. Is left or right? What's the name? Oh, it's private, sorry. Let's do it public. Calculate left or right. So right here, I'm getting the text from a message I'm going to save. I calculate if it's left or right. And finally, oh sorry, set AI And finally I set the value. Let's do it step by step so you can understand it better. Let's do it like this. String left or right equals the calculation from the artificial intelligence. And finally, if I have the value, dot set AI bias left or right. And with that, we're saving the new messages with what the AI considers if it's left or right. Still doing the training. Let's see. The Stack Overflow, I know maybe why it happens. Maybe something with an array, because I saw Stack Overflow. So maybe the error is somewhere over here. Oh, equals. I don't know, man. Let's see if we see the error. It's taking a long time. Natural language trainings always take a long time. I've done other kinds of knowledge-based trainings in which I relate values from a database from other values, and that's always very quick. But language is always heavy to the AIs. We as humans are very, very, very strong in our computation abilities to be able to talk and speak. We are special. So trying to imitate that is difficult, but we're there. We're almost there. Trying to make machines speak like humans, but as you have seen with ChatGPT, some things are not quite as human. You can detect some stuff. It can pass some tests, for example, but if you look into it, sometimes you can see that it's not a human. Let's see what's this doing over here. Maybe I have to debug, because this is like an infinite. I think it's oh, aha, we got the error here. We got a Stack Overflow because I think our memory got blasted into space. Let's see. We don't even see the exact place of the exception. Okay, here we are. Let's see if the training is not okay. All the messages. Get the words. Right. Let's see. Let's just do it for one message, because I don't get it. I don't get what's happening over here. So let's do just one message, debugging, to see what's wrong over here. Let's do a complete run of the training. Maybe I missed something somewhere. I'm not a perfect being, I'm a human being. So let's see. Let's train. It failed very quickly. And right now maybe we can get the problem, because it's not giving us the place of the problem. So let's put a breakpoint over here and see if we are doing everything fine. All right. Words. So we have the first word, which is Florida. Number value. So input, as you can see, has 333, which is the Florida name, Florida value, Florida number value in our database. So if we see in our database, in our Word database, and we find Florida, its number value will be 333. So far so good. So the second word is will, right? You can see here will, and in our database, will has the number 1. That's awesome. So far 3, 2, 1, 2, we're doing fine. 3, right? So far it's doing that well. All right. So this is the input that we're going to give to the neural network. As you can see, we have no words in that array, we have only numbers. So far so good. Let's see, left or right. So since the first message from Governor DeSantis is from the right side of the spectrum, we have a 1 in the number, in the result array. Let's see. Break. Okay. This is the training part of the process. And in here, I think we have the error. Let's see. No. Here's the problem. In this part over here. Why it's not saving? Maybe it's a security issue. Oh, it didn't give an error. Okay. Oops. What's this? Oh, sorry. Let's start from scratch. Let's start from here, from save. Let's do the training. Alright. So I think the problem is there, but I'm not sure. Yes, you see? Oh, still running. Aha. What's that? What is that? I don't even know what's that. Error outstanding. And I don't even know where's the breakpoint right now. Let's see something else over here. Yeah, that's the way. That's the way to do it. Let's see if the file is created. Yes, here it is. Here's the file. So the file is being created, at least. So we can use this file to maybe... Oh, here's the exception. So maybe when it creates the file, our antivirus or something is being triggered. Maybe it's that. Let's see. So it's when you save the file. When we save the file, it fails. That never happened to me before. But here we have the file. Let's see. It's a 700 kilobyte file. Let's see that at least if it works. NNet. Where is it? Oh, here it is. And I'm going to add an empty file for this test. Perfect. So we have the AI file as well. And if we try to save a message, it should run the neural network. Because the problem is when we save the file for some reason, but the file is what the neural network uses to run the tests. So right now we're going to save the message and we're going to see if it detects if it left or right. Let's see. This is a test message, very impartial. Let's see. So this is the calculation. Let's see if it runs. It failed. Let's see why. Oh, it's null. All right. No, it's not a heavy error. Oh, I know what's the problem. Yes, I know what's the problem. I can fix it quickly. The only way to know if the training has been finished is by having this status. So I have to put that status. My bad, I was missing that. So this is not a pre-training. This is the trained. So the ones that have this are the ones that are being considered for the AI file. So this is a very impartial text message. Let's see. And it worked. Or not. Or thinking. Wow, it takes a long time. What is it doing? It's very slow. It has a Stack Overflow. Maybe I need to use a smaller artificial intelligence because it's failing too hard. Let's try again with a smaller input layer. Yes, because it's giving a Stack Overflow. Maybe the AI is too big. So I can increase the RAM, the memory available for this project, but let's do it with a smaller size. Input size. How many words can a tweet have? Let's add 75 just in case. Oops. And 254. Let's try this because maybe the AI is too big. All right, let's do this all from scratch. Let's create a pre-training. This will be faster, of course. And then we're going to add Bernie Sanders from the left. And after that we're going to see, oh, I didn't run the project again, did I? We shall see. For some reason, this takes longer, but it's done. Perfect. So I'm going to stop this. I'm going to run it again just in case, and we will do the training. After that, it should work. Let's see. All right, let's try. Awesome! It worked. It was that. Maybe sorry, the AI was too big, so I will take that into account. And now we're going to try a message. Let's create a new message. Let's see, an error. Okay, what's the error? The same error. Stack Overflow. Some words are not there. Why? Oh, I remember I had to remove a breakpoint from somewhere. Right? Yes. Let's do this first and then that. Let's first fix this problem. This kind of words, I will skip it for now. Alright. I remember the training resource. I had a break somewhere. I don't remember where. Yes, it was here. It was in the training, so I have to do the training again. Let's see. Hopefully it won't fail. I think it's doing something wrong because it's doing the same thing several times. Oh, this training is taking way longer, but it's fine. Let's see if it compiles the file correctly. Maybe I can add less neurons in the hidden layers as well. Sometimes there are too many. It's way big, way too big. Can do a quick bathroom break. Be right back. Okay, I'm back. Let's see if this works. Hopefully this time it won't crash. Let's see. I don't know why it runs several things several times. Listing entities, just printing entities. Wow, it's so long, and we're not even using thousands of messages, so this needs to be optimized a lot. It's just that. Let me see if I can see something here. Words. Yeah, basically. That's it. Find by name. Number value. I should have here 75. Oh no. Wow, it's taking so long. So long. Maybe I was doing something wrong over here as well. Let me see. Wow. Well, at least it's not crashing, so. The training is always a process that takes a bit of time, but it shouldn't take so long. I think it's taking longer than it should, because our training data is not as big. Also, the A is not as big as well. It's not as big, so I don't get what is taking so long. Maybe it's because of the output. I don't know. Maybe I can avoid all the outputs. Log level. Wow. It's taking so long, man. I think it's because of the logger. Let me see login configuration. Logger configuration. Finally, it's done. Awesome. Well, we can improve that later. Awesome. So cool. Great. Now, let's finally create a message. A very impartial message. Impartial. Let's see. Left. So this very impartial message is from the left. Let's see. Let's write something from DeSantis himself to see if Mr. DeSantis is from the right or the left. All those messages, man. Oh, I'm from the left. Nah, this is wrong. This AI is not working. So let's see at least if this is being calculated correctly. So the AI is working, the training is working, but the test data is not doing so well. So let's see what's wrong. Maybe we can improve it. Maybe I'm doing something wrong. Over here. Let's see. Test message, very impartial. Okay. So the AI is working now, and we are going to see how it processes the data internally. So we got the file. This is the neural network. We have the input. Test message, very impartial, right? This is number value. We found that test has the number 7491. Message is the word number 4140. Very is the 4559. Well, it's working. I think it's working. So by the end, test message, very impartial. Impartial is a word that's not in our vocabulary, you see? So right here we have a 0. So our artificial intelligence doesn't understand the word impartial. That's not good. So let's see. If we can, okay, the output is 0 and 0 is left. So let's put output 1 result. This is wrong, so let's change this to left or right. I think it's because we have too many messages from Bernie Sanders. So I know what I will do. We will do a very easy test for that, and the training is going to be very easy. So because I'm doing the test with real data, and it's giving problems. So let's create a new message. From a right-leaning person. Let's see what happens. And say left. Okay. It's not working. So let's train our AI again. Let's delete, and we're going to do a very easy training with small data, so we can't go wrong. So left leaning, and we're going to use words like left, or let's copy. Oh, I know what to do. Okay, let's do things that are from the left. Okay, but very easy. For example, gay rights, for example. Black Lives Matter. Yes, things like that. What else? We are liberals. Okay, just three strings. Oh no, let's change this to right leaning. We are conservative. All right. So let's try this. So this is left, right? Very quick. This is right leaning, right. This is very quick because just 3 lines. And now we're going to train. And the training takes so long. What's this? Students Expand Massacre. What's that? I don't even know what's that, man. Oh, I understand what it is. Sorry. I know what's taking so long. I know why. It's my bad entirely. It's because the message table has a lot of information. So let's truncate it. It was my bad. Sorry, man. Sorry about that, guys. Guys and gals, just like Murahara says. Yes, it was my bad. So right now, this should be empty. Let's see. Oh, it's not running. Now it is. Yes, it was taking a long time because the database was full of messages. Too full, actually. So right now, it should be easier. So if we see message, it's empty, Word is full, training, perfect, let's train. And it's really quick. Sorry about that, guys. So now, oh, because I deleted everything, sorry. I have to do everything from scratch. Delete, create a new pre-training. From the left, from the right. Let's see if the messages are correct. Yes. Let's train. Trained perfectly. And let's create a new message and let's say gay lives matter, for example. It's wrong. It said it's right. This AI doesn't know how to differentiate, but at least it's saying right now. Before it wasn't saying anything. Black Lives Matter. What? This is a left mess. Everything is right now. Nah, this AI. Let's copy this to see if it at least everything is right now. Nah, this AI is not working. Well, it's very small training data set. So let's make it even easier. Let's try with just one word, since we are using such a small training data. Let's train something better. So we're going to use only words. Like for the left, we're going to use liberal, love. And we're going to use for the right can ask God what else? What is it? I put 6 in one, right? 6, yes. Server. I don't know which other words I can use to describe the right. Right. Let's do this for now. With only words. Right. Left. Train. Training is complete. Good thing the training is really fast. And if it's fast, it means we're basically not doing much for that training. But why is everything right here? Oh, this is wrong. I have to do it again. Okay. Pre-training. Left is left. Right. Left, 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 right, right, okay. Let's try this. Error. What's the error? Oh, I think I'm not adding new words. I think that's the problem. Training is null. Oh, okay. Let's try again. Why is it saying right? I don't get it. It's not working at all. Maybe I have to make a smaller AI. Good thing we have a small data, because I think I have to make the AI smaller. do that. So let's do like 20 here, 10, 5, 3, 2, and finally 1. Let's try that. Maybe sometimes when the AI is too big, it doesn't work. Let's delete this. Delete this. Delete this one. We train. This one is way smaller. It always says they're right. I don't know why. Liberal. Let's see what's happening while we debug. But at least the AI is working. It's not working as intended, but it's working. Okay, so let's see why it's not working. All right. The tweet is help. So the number value is 361. How many words can a tweet have? So imagine $75 fine, right? For an amount of words. That's the thing. There are too many blank spaces. Maybe those blank spaces are the things that are giving a problem. I know what I will do now. Oops. Of course, the output was 1 from the right, but I don't know why. Even with that, having all rights, all lefts and no rights, I don't know. Let's see if our AI ignores the right, if we don't have any right. To see if at least our AI is doing something that makes sense, because I don't know what's happening. We will only have left-leaning tweets. So let's train that way. Check this. Oh, I know something that could be happening. I'll do something else. Let's delete this and try again. Maybe that's what's causing some kind of problems. Okay. Let's create a new message saying whatever. And if it says right, then our AI is okay. It says left, so we're not crazy. I will do something better now. Instead of 75, I will make it even smaller. Let's do it with 25 words only, to see if that helps. Oops. So this way, I think it will help a lot. I think having too many words is breaking this. This is part of the AI development, always. It's something that always happens to me when I create artificial intelligence applications. We always have to tune the training, because the training is a very fundamental part of the AI development. Sometimes you have to resort in doing some techniques and ways of training that sometimes will help you improve the way the AI works. And yes, this is something that I always have to tweak the training. So let's run it again. Let's do this like a left spectrum, political words. I wish I could do it with the tweets, right? Let's do it with the tweets, man. Let's do it with the tweets. Right now, at least, the AI is quicker than before, so let's do it with the tweets. Because looking for words, it's actually what I want the AI to do for me. So let's do it with the tweets. So Bernie Sanders and Ron DeSantis. And let's clean this a bit. Yeah, it's okay. It's okay. Let's do this. Ron DeSantis. But he gives a lot of things that have several lines, so let's get something better. Oops. Let's do from 3,200 to 3,000. 200. I think this is better. And for Bernie Sanders, the same. All right. Let's do this. Let's see. Hopefully this will work. Everything's going to be fine. Let's go to messages. Everything is deleted. Okay. Words, we still have them. Let's do the training. This is going to take a while, but I don't think it's going to take too long. This output is taking all the memory, man. Let's see. Here it is. Logback strain. Should I say off? Yeah, right. Just for now, because the training is taking so long. I don't know anything now. Anything what's happening now. Everything is off. Well, see the messages from the right. Okay. Pre-training from the left now. Is left. Save. It's way quicker now. So awesome. You can see the tweets in real time now. Wow, what a relief. These tweets are not so good, but no problem. I have to fix these tweets. I have to delete all the breaking spaces. I have to clean that data. Almost there. A list of countries can be left or right. So this data has to be normalized as well. As I was saying at the beginning, not all tweets are, or not all tweets from a political figure have a spectrum orientation, right? So not all messages are right or left. Some messages are just neutral or are just happy birthday, for example. Some things that not necessarily are considered to be part of a spectrum. So I have to clean all this data better so we have a better training, but for now let's see if this works. All right. All these messages are here. 600 messages. It's not too much. And now let's do the training. Okay. Created the neural network. Maybe I have to print something else there because I don't even know if it's doing it right. Still working. Right now, I consider this AI as a proper AI. I think we have to improve is the training data. The training data is the thing that's giving problems right now, because right now the AI is able to receive data for training and then using data to process the information and give a result depending on the training data. But if the training data is not good, it's not normalized, it has problems like single words with no meaning or sentences that have no discernible spectrum, political spectrum orientation, for example, things like that. So that way we're not able still to know, but we will soon. Let's wait for a bit for this training. Let's see if the processor the memory is fine right now. CPU having a bit of a struggle with the database. The database is being accessed a lot. But it's fine, it's reading. Right now it's still filling the dataset for the training, so it's still on this part over here. Let's see, it's in this part, in this loop. Right now it's in this loop after this output. But it's going well. It's going well. Oh, awesome! Training successful. That's good. That's good. Right. Training successful. The file is 37 bytes, 37,000 bytes only. And let's do a test. Hello. My name is Developer. Nice to meet you. So I just created a left-leaning message. Let's copy for example this from Mr. DeSantis himself to see if the AI at least tells us that this is a right-leaning message. No, everything left, man. Why, AI? Why have you failed me? Sometimes it always... oh, I know what can I do. I can do something better, guys. Let's do something better. Yes, yes. When this happens to me, I separate the outputs because it's giving me too much problems, too many problems. So I know what I will do now. So in the training, in the structure of our AI, I'm going to change from this to this. I'm going to add another output here. If this one is 1, we have right. If this one is 1, we have left. If both are 1, then it means it has components from both. We can do something better. Let's do something better. This is the last change I'm going to do to this AI. And with that, we close this chapter, this streaming session. It has been great. I have been enjoying it a lot. And this this stream is a bit more technical than the rest of the trainings I want to do, but the next one are going to be a bit easier, like games and apps, stuff like that. Okay, so the output size is going to be 2. So if it equals left, result 0 is going to be 1, and result 1 is going to be 0. Let's see if this changes everything. So if we have a left-leaning message, we add 0 in one and 1 in the other. Let's see if we are fine here. Yes, 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 yes. And finally, when we calculate, we have to change that structure as well. So when we get the output over here, if we have 1 here, we have left. Oops. If we have a 1, but if we have nothing, we say neutral. Because sometimes a message can be neutral, right? Like hello. Hello is not left or right. So the training is difficult. I think it's the most important part of the AI, the training. Because you can have the best AI in the world, but if you don't train it well, it doesn't know what to do. It's fundamental. So let's do it. We change the output. Instead of having just one output, we have 2. If the first output has a number 1, it means our message has left leaning properties. If the second value is 1, it's the other way around. But if both values are 0, it means we just have a neutral message. Let's try that. We have the pre-training, everything. Let's train. It's going to take a bit of time. I'll be right back. 1 second, please. All right, I'm back. It's still training. This training takes a bit longer because I guess there's a lot of messages to read. Let's see. Let's see how it goes. In the meantime, let's see if everything is fine. Output. Yeah, it's fine. I will, of course, upload all this project, the code, to GitHub. The link is in our profile page. If you want to download it, you want to use it in your projects, to learn, to modify the AI, use it for other projects, to conquer the world, whatever you want, it's free for you to use. Use it for good, of course, please. Don't destroy your world with AI. Use AI for helping humanity progress. It's very powerful and helps a lot. Oh, an error. Where? Gave an error. Ah, it can't be, man. Where is it? I thought I changed that, right? Oh man. Well, I remember I added like a try catch. Oh, it wasn't in the training. It wasn't in the training. Well, let's just add a try catch over here. And with that, for now, I will skip that word because it's a rare it's rare that it happens, but yeah, do the training again. How annoying. Oh, no problem. All right. Maybe it was some random value in a word or something. It happens. From time to time. So the training is not here. Let's train again. Right now, the AI, since it's not working well, it's not as impressive. But when it works, oh wow, it's like magic, man. It's so impressive. The way it is able to discern from different inputs, something that has always impressed me a lot. AI is really nice. I think it's one of the most interesting things in tech right now, and has a lot of attention from the media, and it's always in the news. People love AI, and some people are scared of it as well. But I think AI is always going to be something like a tool. Every tool can be used for good or evil. Every technological achievement we manage to create is always going to give us a path for destruction. Everything that's powerful can be used for good or evil, I think. And since AI is something so powerful right now, I think people the people that use AI are going to be the ones that are going to transform the world, and it depends on good people to use it for good. And hopefully the governments will give some kind of regulations in the future, because since this is something really new, right now there are no rules on how to use it or on who to use it for what. So maybe I think while we see new and more powerful tools and AI powered applications, we will see how the world will change. It will change a lot in the way we drive, in the way we interact in social media, even our technological security, our everything. I think some hackers are using AI a lot right now in botnets, for example. So we have to be careful. The training was done, was complete. Awesome. And now let's do the test. So it's a right-leaning message, this one. So since this one is from the left, oh no, sorry, this one. Let's see. Neutral. And if you check it, it's really a neutral message, right? So let's see if we can find something from the left. Let's see. He's talking about Trump over here. That's always something that will give some kind of message. It says this is a right-leaning message. You see that? Let's see if we can get one from the left. These kind of messages, this is not a good training, guys. Sorry about that, but as you can see, we are improving. And I think if we, for example, this training data is really bad. This is just a country name, and we're saying this is from the left, and it's a wrong kind of data for training these ones as well. So I think if we improve the training data, I think the AI is going to be really nice. I think this AI with this better output with the size of two, with an array of two spaces, is better. It's way better. But yes, I think what happens if we say this: Black Lives Matter and we need gay rights. Let's see. It says this is from the right. This is definitely not from the right. But yes, I think it's because of the training. Because the training's it's not so good. Let's try something from the right this time. I am a conservative and we need Jesus. Sorry, God. We got it right, guys. This AI is the best. But yes, I think right now the AI has been completed. It can be optimized way more, of course. I think I can use a better training data. Since tomorrow I will have a bit more time to do it, I will clean these tweets. I will make them have only one line, no simple words, tweets that we're saving here with just one word, things like that. And I will share the code of this project so you can use it, improve it if you want. And I will also include 2 Excel files with the training data. If you need to use the data, you can also create your own training procedures. You can use a normalized, clean, and better structured data to fix this. But as you can see, we created an AI that's able to read a tweet word by word, assign a number value to each word, and with that it's able to detect some patterns in what we write. For example, let's see what happens if we write just one word. What happens? Oops. Word. It's neutral. So this AI is not perfect, but I think we improved it a bit. And I think right now it works as intended, but the training is not good. I think that the training is what needs improvement. I will give you guys, as promised, a project with containing a file for the training with normalized data and cleaned. And with that, I think we can have a very powerful AI with the correct training. And with that, guys, we can finish the stream for today. I really enjoyed having this stream with you guys. It was really great. I love to develop and create things for you, and so you can learn how to create the things I do with love, and so you can do it yourself, or you can use them for your projects. And with that, guys, I thank you and say to you, see you in the next stream. It was awesome, and take care, guys. Bye bye.